All right, guys, now that we have talked a little bit about inverse trig functions, now we're going to talk about their graphs. Okay, so first things first, let's evaluate these without a calculator if possible. So look at the input, decide if it exists within the domain, and then see if you guys can figure out what it would equal. All right, go ahead, put me on pause. All right, so first things first, let's look at this tan of arctan of 36. So arctangent of 36, is 36 in the domain of arctangent? Well, if the domain is all real numbers, yes it is. And since we have tangent of arctangent, this equals 36. Think about what inverses do. They, quote unquote, undo each other. It's like addition and subtraction. Here, I have sine of sine inverse of negative 0.3. Is negative 0.3 in the domain of inverse sine? Yes, because the domain is negative 1 to 1. So therefore, this equals negative 0.3. Now the arc cosine of 36, the domain for arc cosine is negative 1 to 1. So therefore, 36 doesn't exist in the domain. So therefore, does not exist. Here, now this is reverse. I have the sine of 5 pi over 4. Well, that is negative root 2 over 2, which is in the domain of inverse sine. So therefore, it's negative pi over 4. Okay, think about the range for inverse sine. Okay. Also, just like how we were checking if things were in the domain here, I know that the domain of sine is all real numbers. Okay, that's why it works here. The tangent of pi over 3, well, we know that that's root 3, which is part of the domain of inverse tangent since it's all real numbers. So we get pi over 3. And last but not least, the tangent of 7 pi over 4, well, this is 1. So the arc cosine of negative 1, sorry, I meant to say negative 1. This is negative 1. The arc cosine of negative 1 is pi, because think about your domain and range for arc cosine. Awesome. So to kind of summarize this, under what conditions will sine of arc sine of x equal x and arc sine of sine of y equal y? Same thing for cosine, arc cosine, and tangent and arctangent. So use these examples to see what we can notice. Okay, so now let's move on to some graphs. So inverse graphs are not periodic functions. You know, think about when we were graphing sine and cosine, we just could continue on with the period and would repeat itself. But the inverses are not periodic, so these will be a little bit different. So it says graph y equals arc sine of 2x. And before we do that, I think it would be helpful to just graph what, oops, not sine of x, arc sine of x. Okay, well, if I think about what that's going to look like, well, I know the domain for arc sine is negative 1 to 1, and I know that my range is negative pi halves to pi halves. That was my restricted domain before. Okay, so now let's think, well, what's arc sine of 0? That's 0. I should label these. What's the arc sine of 1? Pi halves. And the arc sine of negative 1 is negative pi halves. Now, also to kind of understand the shape of what's happening in between here and here, you don't have to do this, but I'm just going to show at negative 1/2 and 1/2. If I did the arc sine of positive 1/2, I would get pi 6, which is closer to 0 than it is pi halves. And if I did the arc sine of negative 1/2, that's negative pi 6, which again is closer to 0 than negative pi halves. So now here's what my curve looks like. But we actually want to graph y equals arc sine of 2x. So this is where we just have to think about transformations, okay? Think about what does it do when we multiply 2 on the quote-unquote inside of the function. We multiply our x values by 1/2, which is the same thing as dividing by 2. So let me do this. It's 1/2 pi over 2 negative pi over 2. So if I multiplied my old x value of 0 times 1/2, that would still stay at 0. My old x value over here was at 1, so now if I multiply by 1/2, that's going to be at 1/2. And same thing for over here. It was at -1, now it's going to be a 1/2. And the graph kind of looks the same. Okay, so let's try arc cosine. Same thing. I want you guys to try this one on your own. I would start by figuring out, well, what does the graph of y equals arc cosine of x look like? And then apply the transformations of going left 1 and down 1 to that. Okay, so go ahead and try this on your own. Okay, so just for us to understand the graph of y equals arc cosine of x, remember our range is from 0 to pi. So that's really a big thing that looks very different compared to the arc cosine. Also remember that our domain is -1 to 1. So if I just kind of think about, well, what's the arc cosine of -1? The arc cosine of 0 and the arc cosine of 1, that should help us figure out this graph. For this one here, we just had to apply the transformations of going left 2 and down 1. So if I do that, I'm going to take all of these 3 points, move it to the left 2 and down 1. If you're not understanding where I got this from, read my ordered pairs and figure out, how did I go from one to the other. All right, next one is the arctangent. So we have y equals 2 times arctangent of x plus pi. Once again, I would start by figuring out, well, what does the graph of the arctangent of x look like? Now remember that our range is from -pi/2 to pi/2. And when it was in our domain, we had vertical asymptotes. So what do you think is going to be true about our having that in our range? All right, let's see what you guys can do on your own. Go ahead, put me on pause. Okay, so arctangent of x. Remember I was saying that our range is from -pi/2 to pi/2. And in our tangent graph, those were vertical asymptotes. So now they become horizontal asymptotes in our arctangent graph. We know that if I had arctangent of 1, that would be at pi/4. Arctangent of -1 is -pi/4. And since our range is all real numbers, it continues on and on, left to right. We have the transformation of multiplying our y values by 2 and then adding pi. So remember, for my asymptotes, I'm going to multiply those by 2, my asymptotes by 2, and then move it up by pi. Okay, so here my new asymptotes are at 0 and 2 pi. And I'm going to do the same thing with these points. I'm going to multiply the current y value by 2, which is 0, and move it up to pi. Same thing here. Multiply the y value by 2, move it up pi units. And this is what I get. Okay, so next, let's evaluate the inverse sine of cosine of 5 pi over 6. Let's have you guys try this one on your own. All right, so the cosine of 5 pi over 6 is -√3/2. So the inverse sine of -√3/2 is -pi/3. Think about our domain and range. Input, output. Next one. Evaluate sine of arc cosine of √5/5. Again, this is not a unit circle problem, so we're going to have to draw a triangle. So let's go ahead and try this one on our own. Okay, so the first thing is figuring out, okay, how am I going to draw my triangle? Well, we have a positive input, so we know it's going to be in the first quadrant. Because think about the range of our cosine, and then we have sine of our cosine. Okay, so that's how we can figure out that it's going to be in the first quadrant. Okay, so again, positive input, we know it's going to be our first quadrant. So once we can draw this triangle, we use our Pythagorean theorem, figure out the sine of theta, which is 2√5/5. Next one, cotangent of arctangent of 5/8. Again, let's draw a triangle. Or maybe you don't have to. All right, so cotangent of arctangent of 5/8 is 8/5. How do we know that? Well, I said you could draw a triangle. Maybe you could realize the relationship between cotangent and arctangent, or just tangent, and understand that's just going to be the reciprocal, so maybe you don't even have to draw one. Last one, write theta as a function of x. Go ahead. All right, here's my theta. as a function of x. So I first wrote tangent of a theta is x plus 1 over 10. So to solve for theta, I took the inverse. So I have theta is inverse tangent of x plus 1 over 10. All right, so in conclusion, when we evaluate the composition of trig functions and inverses, we want to work from the inside out. If values or angles are on the unit circle, then use the unit circle. If they're not, then we're going to draw a triangle. And don't forget to check to see if the values are within the domain and make sure that the angle is within the range. Super duper, duper duper dupity important. That's not a word. Okay, bye.